Hello everybody, Kelvin here, and we are back with another video for the CCNA Security. It's been a while since I've actually done a video for CCNA Security. However, for those that are subscribed and follow, most of my videos are security related anyway. So this video is going to focus on one of the labs taken from the CCNA Security Lab Manual version 2. And as you can see on screen there, it's 6.3.1.1, securing layer 2 switches. And in brackets, I've kind of put modified, and the reason I've put that is because I've slightly changed a few things to make the lab a little bit more interesting. And you're going to see why as we go through the actual lab. So for those that are following along, I am using Eve NG. You can use GNS3, you can use physical equipment, and I believe you can use packet tracer. However, when you start using, or when you start learning the CCNA security, it's best to try and move away from packet tracer and go into stuff like, viral GNS3 or even Eve NG. Providing you've got the images, that is. So we're going to jump in now, and I've put together a task list here. So these are the steps that we're going to go through. So we're going to go through configuring host names, IP addresses and passwords. We're going to configure SSH version 2 on the switches. And this is where the modified bit comes in, because what I'm going to actually do, instead of using the VPCs that I have with my topology, I'm going to connect to, or I'm going to attempt to connect from my physical machine that we're using now to the switches in the virtual environment. Then we're going to take a look at STP, or spanning tree protocol. And we're going to do some configurations around there in relation to root bridge. And then we're going to look at configuring trunk ports. We're going to change the native VLAN, because we all should know that default VLAN 1 on Cisco devices is not the best way forward in terms of security. So whenever you can change that, you change that. Then we're going to look at turning off dynamic trunking protocol. And then we're going to move on to configuring port fast on the access interfaces. Then we're going to start looking at BPD UGuard on the access switches as well as root guard. And we're going to enable port security, and we'll test with some violations there by changing the MAC address, before moving on to disabling unused ports. And we're also going to create a VLAN for those unused ports, so that if there was ever a time that these ports were enabled, there's no way that they could access the actual VLANs that are being used, because they're just in a black hole VLAN essentially. Then we're going to look at private VLANs, and we're going to try and configure some private VLANs. Now I'm not sure if this is supported on the switches that I'm using, but we're going to certainly have a look at it and see if we can configure that. And then last but not least, we'll configure DHCP Snooping, and we'll do some verification commands on everything that we've done. So without further ado, let's jump in, and if we basically just work our way down the list. So we're going to start by configuring the host names, IP addresses and access passwords on each device. So we'll do that. So the VPCs we don't need to worry about, so we're more focused on the switches and the router. So as I said, this is a modified lab. I'm slightly modified it, taken from the CCNA Security Lab Manual version 2. So what we're going to do is we're going to start by configuring the host name, so conf t, and then we'll just do host name, and we're going to call this S1 for switch 1, and then we'll do, looking at the IP address in front of us on the screen, we're looking at VLAN 1, so we'll do interface VLAN 1, which is the default VLAN. We'll give it an IP address of 192.168.2.1/24, so it's 255.255.255.0, and the state will just issue a no shut. Okay, cool. And we'll do well, maybe we won't do no IP. We don't need to do a no IP domain lookup because we're going to need to generate keys anyway. So let's do a secure password for this. We'll do enable, and we'll see if it's supported. So yeah, so algorithm type is a way of setting a more secure password other than secret. So if you just have a look, algorithm type, and then we look at the options available. So we've got MD5, we've got script, which is what we're going to use, and then we've got SHA-256. So we'll use script, and then we can assign the password. So our password will stick with the lab manual for those that are following along. I won't try and divert too much from that, just to make it easier for those that are following along and maybe do have the lab manual. So it's Cisco 1 2 3 4 5. So if we just do show run, you can see that we're using a type 9, which is script, and our password is hashed, and the $2 the salts, the $3. Okay, cool. So we'll do that as well for switch 2, and we'll also do it for the router. So same procedure, hostname, switch 2, interface VLAN 1, IP address 192.168.2.2/24. Now do show IP in brief. So we can see there that we have an IP address now, and then we'll do the same for the password. So enable, algorithm type, script, and then it's going to be secret, then Cisco 1 2 3 4 5. Okay, cool. So that's that one done. And just following along with the lab guide, it's not really done that for the router because we're more focused on securing the layer 2 switches. So as good practice, we are going to do it on the router as well. So feel free to follow along or stick to the lab manual. As I said at the start, this is slightly modified, so we will maybe delve and divert a little bit. Okay, cool. So hostname route 1, and we'll do interface gigabit 01, IP address 192.168.2.1/24. No shut, and exit out of that. We'll do enable, algorithm type, script, secret, Cisco 1 2 3 4 5, and then we're done with the route 1 for now. So let's just configure the IP addresses for the virtual PCs. So we start with VPC3, which is the left hand side connected to switch 1. So IP 192.168.2.10. Default gateway 192.168.2.1. And for those that are using physical machines, yeah, just basically set the IP address to what's given in the lab. I'm using a VPC, so it's the same process. I think it's show. So you can see there now I've set my IP address and my gateway is set as well. So I'll do the same there for VPC 4. 192.168.2.11. Gateway is the same, 2.1. Let's verify that IP address. That's cool. Now let's just quickly test connectivity. 192.168. Ping 2.1. There we go. So I can get to the gateway, which is router 1. Cool. And we'll verify connectivity from VPC 3 as well, up to the gateway. First one will time out, and then the rest are successful. So if we do it again, they'll all be successful. Okay, cool. So we verified connectivity, we've configured the host names, and we've configured the IP addresses as well as enable passwords. So if we just take a look at our lab details, and those that are following in the lab manual, take a look at the lab manual. We're now going to configure SSH on the access switches, and we're going to use version 2. Okay, cool. So we'll start with switch 1. Duplicate address. Let me just. That's my fault. Should be using 2.2. So in the first VLAN 1, let me just remove that. No IP address. IP address 192.168.2.2. And I'm going to just verify this config. So that's using switch 2, so that should be 2.3. So this is my mistake. And the first VLAN 1, my IP address. IP address 192.168.2.3. And we should be good now. .3. Let's quickly copy that so I don't have to write it again. .2, that's correct. So that should be all good now. So we'll just verify connectivity again. And there we go. So we can still get to the gateway now. We'll do the same for that. Yeah, so we're good. So back to SSH. So the reason I didn't configure an IP domain lookup, because to generate the keys, we need to have a domain. So we're going to do that now. So I'll do IP domain name, and we're gonna call this one voicekit.com. For those that are following a lab guide, I believe it's IP domain name CCNA Now we need to configure a username. We'll do username admin, and we can give it privilege level. If you do, it'll give it privilege level 15 automatically, but we'll follow along with the lab guides of privilege 15. And again, algorithm type, and we're going to use script again, and the password Cisco 12345. Just do show run. We can see there now that we've got an admin user with privilege level 15 using a type 9 password. So once we've done that, we need to generate the RSA key pair. So we'll do that now. Crypto key, generate RSA modulus. In fact, we'll generate general key. So if I just do that, generate general purpose key pair for signing and encryption. So we'll do that as per the guide. General keys, modulus, and 1024, not 2048 in this lab manual. We'll generate that. And there we go, that's been generated. So we'll just do show run, include let's do a show run. I just want to verify I don't show it. Show crypto. Public key, so that'll be the public key RSA. So there's our key name. So it uses a host name, then the domain name. Okay, cool. So we've done that, and now we need to verify that we're on version 2 SSH. By default it should be version 1, I believe. Let's just do show SSH, the IP SSH. So we're actually on version 2 by default now. But yeah, and there's the key. But if we wasn't, and we can see the key size here, 1024. But if we wasn't, then what we'd do, it would do IP SSH version, and you can see 1 or 2 there, so we'd do 2, and do show IP SSH again. Sorry, so yes, sorry, we was on 1.99 is version 1. Now we're on version 2 here, as you can see. So if we just scroll up, version 1, version 2 there. So that's how you change it to version 2 and generate key pairs. So looking at the lab guide for those that are following on, there's also some commands to for the timeout of SSH for sessions. So what we do is we do IP SSH. We could see here with the question mark we've got the timeout interval, which is here. So we're going to set the timeout interval, and if you do question mark, this is in seconds. So let's just do 90 seconds. And we'll also do the IP SSH authentication retries. So this is, so again, let's just show you this for clarity. So this is this allows you to specify the number of times you can retry authentication. So we're going to do 2 as per the guide. And then we need to allow this on the VTY line so that we can actually test this. So we'll do line VTY, and as per the guide we'll do 0 to 4. Privilege level 15. Do exec timeout. Is that? Yep, it is. So we'll do the exec timeout of. So again, this is seconds, minutes, and seconds. So 5 minutes, 5 and 0. And we're going to specify login local. So it's going to use the switch's local database to log in. And our transport method is going to be SSH. We could have telnet as well, but it's insecure. So being a security lab, we disable telnet by doing transport input SSH. So we'll do input. We can see there the options that we have. So we're just going to use SSH. So we could do all, but that's not secure. So we're going to do SSH. And then if you wanted to do SSH and telnet, then you do input SSH and, well, the telnet, but we're just doing SSH. And we'll exit from that. And then for the rest of the VTY lines, so we did 0 to 4, so let's just say for the rest, so line VTY, let's just do 5 to 15. We're going to do transport input none. So this isn't going to allow any connectivity to this. So what we'll do now is we'll just do a write mem or copy run start. Save this configuration. And if you're following along in the guide, we can see now that on the next steps we have the option to install an SSH client such as PuTTY and establish connectivity with the switch. So what we're going to do, this is where it gets a little bit interesting. So as I said earlier, what I'm going to do now is, for those that are following along in the guide, by all means carry on following the guide, but I just thought to make this lab a little bit more interesting, I am going to try and connect from my physical network to this switch and see if we can get connectivity. So what we'll do, we'll just debug as well. Debug IP SSH. and then we should be able to see anything that's coming through as well. So let me just verify the connectivity here. Cisco 12345. Show IP interface brief. So gigabit 01 is 2.1, and then we have the gig 00, which is gonna be configured now. So interface gig 00, IP address 192.168, and I think what I'll do is let's just try 1.45. No shut. Do ping 192.168 1.1 maybe. Okay, that didn't work. Okay, so that works 1.2, so that's cool. So I've got connectivity now to my physical network from the virtual environment. Do show up. Yep, that's cool. So what I'll do is I'll set a default route. No, what I'll do in fact is, let me go back to switch 1, and what we'll do is we'll try and connect first to the, so I'm going to connect SSH version 2, and it was 192.168. the switch is 2.2. Let's try that, and it should fail. Yep, so that's failed. No log, so it's not even getting through there. So let me try and add a route on the PC itself. In fact, it needs to be run as admin. So we do root add 192.168 2. Let's just we'll do the network 2.0. I think it's mask 255.255.255.0, and the gateway 192.168 1.45. I think I give it, was it? Let's just verify that on the 1.45. So now let's see if we can ping 192.168 1.45 from the PC. Yes, we can. Can we ping 2.1? Yes, we can. And can we ping 2.2? Alright, cool. So we can get to 2.1, but we can't get to 2.2, which is the switch. So IP interface brief at 2.2. Status is up. Let's verify the interface is do show IP int brief. So both interfaces are up. So we can get to 2.1. So this looks like we have a routing issue. So what we'll do is we'll add a default route out. So IP route. Can we do that? Is it like the ASA? Nope. So 000, so default route, and we're gonna push this via the next hop of 192.168. Let's say 1.2. Do show IP route. I have a default gate a default route now, static route. So let me just leave this on continuous ping, and then we'll do, let me take a look here. So we have local connected, so we'll do anything destined for 192, so that's right. And let's just go on the switch. So we've got an IP route there. And we'll do, let's do quantity IP default gateway 192.168.2.1. So now we've got a default gateway for this. Yep. That's up. Let me just move this over here. And we'll go back to this, the router. So I just want to take a look at the routing table. Everything goes via 1.2, and then anything destined for network 2.1. So let's put an IP route in here for 192.168.2.0. And yep, 255.0. And we route this via 192.168.2.2. Yeah, that route's not really gonna make a difference because it's already locally connected anyway. But we'll leave that static route in there. So it must be a route on the switch. We need a route to the physical network, so we'll do IP, we'll just do a default route 192.168.2.1. We should start see, yep, there we go. So now we can get to the switch. So what we'll do now is we'll try connect, and as you can see now we are being prompted with a new host key. We'll accept and save, and boom, so we can get in. And if you remember, the username was admin, password was Cisco 12345, and there we go. So from my physical device I've been able to connect to this switch. So let's just do an undebug all. You all. So with the debug on, we can see quite a lot come in here. So we can see the first message was starting the SSH control process. The version 2.0, and we're using 2.0 with Secure CRT, which is the software that we're using. Sent the packet and the key exchange. block size, input. Yeah, so this is all the key exchange process here. Key exchange, derived keys completed. And so on. As you can see, there's a lot of information here. But yep, so from my physical machine that I'm on now, you can see I've been able to SSH to switch 1 from my physical network. So it's come across into the router, then from the router down to the switch. So that's making the lab a little bit more interesting. For those that want to follow that along, you can do so. For those that are following the lab guide, then please stick to what the lab guide is saying. For me to be able to do this, I also added that static route on my physical host. So what we can do now, we can do show users. So we can see that we're on the VTY. So this is the SSH session that we're on now on this, and we're under admin, and then we've also got the console connectivity, which is this switch here. So if I just show, there we can see the idle time went back to 0 as I pressed enter. Okay. Now moving on, now that we've verified SSH connectivity, let's just take a look at the lab details. So we've configured the SSH on the access switches, but we only did it on switch 1. It's not relevant really doing it on both because we've seen the process now. And then we verified that my physical host could access the switch via SSH. So now we're going to configure STP root bridge and change it if it's required, and also move on to configuring trunk ports between switch 1 and switch 2. Okay, for those following the lab guide, I think you start off by, I think this is the actual process in fact, so yeah, we should be good. So it's still focusing on switch 1. Let's just do a do show spanning tree. And we can see that this is a root bridge, which is good. Now if we just had to do that on do show spanning tree, we can see that this isn't the root bridge, which is correct. So it's telling us the root ID here, the address of it. So I'll go back to, let's just move that there so it's easier. So this is the root bridge, MAC address is the same. We can see that on switch 2 the root port is gigabit 00, which is correct. It's connecting to the root bridge. Then the rest are designated. We can see that they're all designated on the switch, the root switch. Okay, cool. So we don't need to change the root bridge because switch 1 is a root bridge, which is how it should be. But if we wanted to change the root bridge, then we just basically change the priorities. The the default priority is here, so 32769 for switch 1, 32769. So there's other parameters that have determined that switch 1 is a root bridge, but what that is it's basically the default priority is 32768, and then you add on the system extension ID, which is the VLAN ID. So this is, it actually says it here. So we could do for on, if we wanted switch 2 to be the primary, we'd do spanning tree for VLAN 1. We change the priority there, or we could just do root primary. Is it priority? No, it'd be spanning tree VLAN 1 root primary. So we could issue that command as well. So if we just do show spanning tree, we can now see that switch 2 is a root bridge. And if we look at switch 1, we can see that it's no longer the root bridge. Okay, so we'll put switch 1 back as the spanning tree VLAN 1 root primary. I'll take this off. Let's go back to switch 1 here. Doesn't seem to have updated yet, so let's do show spanning. In fact, we'll do change that priority, and then if I head over to this one, we can now see that switch 1's ports are all designated. We can now see that this is a root bridge again. Spanning tree. And we can see now that this is not the root bridge switch 2. Alright, cool. So now we're going to move on to configuring trunk ports between switch 1 and switch 2. So we'll do that between gigabit 00 switch 1 and gigabit 00 switch 2. And first gigabit 00. We'll do switch port trunk encapsulation .1q, switch port mod trunk, new short interface trunk. So we can see now that gigabit 00 is .1q and it's trunking the native VLAN default 1, and all VLANs are allowed across it. So we'll do the same for switch 2. Gig 00 switch port trunk encapsulation .1q, switch port mod trunk, do show interface trunk, and and we can see now that that's trunking as well. Show VLAN brief. Okay, cool. That's trunking done. Now what we're going to do is we're going to change the native VLAN for the trunk ports on switch 1 and switch 2. And this by default is good security. So it's VLAN 1 by default, so it's good security practice to change the native VLAN to one other than number 1. So we'll stick with following the guide. So to do that, we'll stay in the interface and we'll stay on switch 2 for now. We'll do switch port trunk native VLAN. And as per the guide, we're going to put 99. And we should start to see a VLAN native VLAN mismatch messages appearing. I'll just hold on. We'll give it a second and see if it outputs that. So yeah, CDP is enabled. Look like it's going to output it. But anyway, we can see if we just do a show interface trunk, we can see that our native VLAN now on this side for switch 2 is VLAN 99. If we do it for switch 1, we can see that the native VLAN is 1. So we need to change that. Normally what you would get is mismatch messages. I'll just do show interface. So it's up. So we'll do the same command but for switch 1. Native VLAN 99. So that's cool now. So if we just do show interface trunk, you can see that now the native VLAN for switch 1 is also VLAN 99. So now we've done that, let's just take a look at our task list. So we've configured the trunks, we've looked at STP, we've changed the native VLAN. Now we're going to turn off dynamic trunking protocol so that it can't automatically negotiate on ports. And we're going to configure port fast on the access interfaces and enable BPD UCard also on the access interfaces. So we start off with DTP. So we're going to set the trunk port to not negotiate. It's just going to stay as trunking. This helps mitigate things like VLAN hopping. So staying on this interface, we'll do switch port. Let's see if it shows us. There we go. So the device will not engage in negotiation protocol on this interface. So we have to manually set it, which we've done already. So it's a trunk. So no negotiate. Do the same for switch 2. no negotiate. So we'll do show gig 00 trunk. So the status is trunking. Let's do switch port. Yeah, VLAN 99 is inactive. We need to create that. Operational mode, administration mode is trunk. .1q encapsulation. Okay, cool. And I can't see, it's there. So negotiation of trunking is now turned off, and this is on switch 2. So if we do the same command for switch 1 before we change it, in fact we have changed that already, so let me just remove that, and then we could have a look. Do show interface gig 00 switch port. So we can see there, before you do that, negotiation of trunking is on. So we change that by adding this command. So if we issue that again, negotiation of trunking is now off. We can verify the configuration on gig 00. I didn't do show interface gig. No, we'll do a do show run type include begin gig 00. There we go. So the reason that didn't come up because it's gigabit Ethernet, and I didn't type that. I just put G, so it won't find it. So yeah, switch port trunk encapsulation .1q. Native VLAN is now 99. Switch port no negotiate, and it's trunking. So what we need to do is VLAN 99 name native, we'll call it interface VLAN 99. So if we scroll up where it said trunking native mode VLAN inactive, let's do the same again. Do show interface gig 00 switch port. So there we go. We can see now that that's showing as native. So let's see what the status is on here, because we need to create this. We can see VLAN 99 on switch 2 is still inactive, so what we need to do is the same. VLAN 99 name, we'll call it native. Interface VLAN 99 no shut. And then we can see that it's come up now. And now we'll be able to get the CDP messages if we add the wrong native VLAN. So we'll just verify that that's showing now, which is right. And what we'll do now is we'll do interface gig 00 just to show you the CDP messages with the native VLAN mismatch. So we'll do port trunk native VLAN 1, and we'll see what happens. See if we get the messages. That's a native VLAN. 192.168 2.1. So it's not showing. CDP is already enabled. Alright, cool. We'll change it back. It was on this one, wasn't it? Yep. VLAN 99. Alright, cool. So that's that done. Now we're going to disable trunking on the access interfaces, so the ones that the VPCs are connected to, because they don't ever need to be doing any sort of trunking. So to do that, we set them to access. So we'll do this with switch 1 first. Interface gig 02, switch port mod access. And we'll do the do show interface gig 02 switch port. So you can see it's a static access now. We'll do that then for switch 2. Interface gigabit 02, switch port mode access. Okay, cool. And should be good there. So we'll also enable port fast on these interfaces. In fact, so interface gigabit 02, spanning tree port fast. So it enables the interface to move directly to a forwarding on the link up. Because it's never going to be participating in spanning tree port fast. Yeah, so non-trunking, which is not it's the non-trunking anyway. And then we'll do the same for switch 1. Keep it 02. Spanning tree port fast. Cool. So what we'll do now is we'll enable BPDU guard, and as per the guide, we'll follow that along. So it's just basically preventing rogue switches that connect to access ports from being able to connect to access ports, and sending BPDUs. So what we'll do on this port is we'll do spanning tree BPDU. We'll see so we've got BPDU guard. We're going to enable that. We'll also do the same for switch 2. BPDU guard. enable, and then we'll do show spanning tree interface G02 in detail. So we can see it's in a forwarding state. It's in VLAN 1. Designated route, MAC address, port is in port fast mode, and we can also see now that BPDU guard is enabled. So it says that it's sent 2077 BPDUs, but now it's in an access port fast enabled. That's switch 2. Show spanning tree interface gig 02 detail. So we can see that this is now the same as well. Okay, so moving on, let's take a look. So we've enabled BPDU guard, we've configured port fast. So now moving on to step 10, we're going to enable root guard on switch 1 that connects to switch 2. So we're going to enable it on here that's connecting to switch 2, so gigabit Ethernet 00. And this also helps prevent rogue switches as well as spoofing. Okay, so I'm gonna add root guard, and if you're following the guide, I believe this is step 3. So we'll just do interface gig 00. Do a spanning tree guard. Let's just do a question mark in fact. Yeah, so we're going to guard the root. Set guard mode to root guard on interface. Do show run include 00. If I would do begin. You can see that we've got a spanning tree root guard now on that interface as well. Okay, cool. Spanning tree incon. So this is what you do. You do show spanning tree inconsistencies, inconsistent part, to show the inconsistent parts. So now that we've done that, so we've enabled the root guard. Now we're going to enable port security on switch 1 and then violate the security. So what we'll do is switch 1. Do show interface gig 02. So we'll take note of this MAC address for that interface. So I'll just copy that somewhere in here. Because we're going to need that after. That's our MAC address for the interface connecting to VPC3. And what we're going to do is we'll do conft interface gig 02. Let's shut down that interface for now. And we'll enable port security by doing switch port security. That enables port security on this interface. G02. So you can see that port security is now enabled. And by default, the violation mode is shut down, and it only allows one maximum MAC address. These are configurable, but that's the default settings. Okay. So what we'll do is we'll shut down, and we'll wait for that to come up. And I'll issue that interface to show interface gig 02. Yep, so that's up. And then from VPC, let's ping to the gateway, which we can. And back to switch 1. We can see that the address is now changed now that we've sent packets. You can see from none to the registered MAC address of the VPC. So if we just do, I'm not sure if it shows the MAC address, but let's have a look. Yeah, I'm not sure it does. However, we can see that that's registered, so this is only going to be, this is the only device that's going to be allowed on this port with the current settings that we've got configured with the total MAC address of 1. So if we add another VPC to that interface or change the MAC address, then it's going to violate that. So that's what we're actually gonna do. That's what we're gonna go do. So let's try and see if I can disconnect this. It might not let me do it, but let's try it. So I tried another VPC. Disconnect. See if I can disconnect this part and add another one. Yeah, it's not gonna let me while it's switched on. So what I'll do is I'll save the config. Do right mem I'll power it down, and then I'll add the other VPC. And all being well, that should have a different MAC address. Okay, so that's done. So I'm just going to go ahead and I'm going to power down this switch. And I'll add the interface again to gig 02. Okay, so that should work now. So I'll power up that switch again. Also power up our new VPC. Leave that one there for now. And I also need to connect to that VPC. That's the new one. And then we have the switch here. So let's just reconnect to this switch. While we're doing that, we'll give this an IP address of 192.168.2.12/24. 192.168.2.1 as the gateway. And then we'll try ping once this switch is back online, and we'll see what happens. Not like it's come back on yet. Let's keep trying to right. Yeah, it's not come back on yet. We'll just give it a second to load. Okay, so it looks like it's loading up now. Okay, so let's see. Show interface. No, show port security interface gigabit 02. This might actually, we might have to do it another way by changing the MAC address on the switch side. So let's just do ping 192.168.2.1. Yeah, so we can ping. So it's registered the MAC address. It's because we shut it down, that's why we had to do it like that. So what we're going to have to do is we're going to have to change the MAC address on the switch side. So what we'll do is we'll do a switch interface gigabit 02. Switch port security MAC address, and we'll give it the MAC address for the interface. So I'll just copy that. Okay, and we'll paste that in there. So it says now the total secure MAC addresses on interface gigabit 02 has reached a maximum of 1. So let's just do show port security interface gigabit 02. Port security is enabled. Okay. So that's cool. So what we're gonna do now is we'll change the MAC address on gigabit Ethernet 02 on the switch side, instead of trying to do it from the VPCs, because it will lose the last source address once we power it off. So what we'll do is we'll go into interface gigabit 02, we'll do MAC address, yep, that's the one. We'll just do AAA BBBB CCCC, exit out of that, and we'll see what happens. Do show port security. Current address count, maximum address count. So there's no violation yet. So port security interface gigabit 02. Okay, so can I do a continuous ping on this? Yeah, that should work. First gigabit 02. Let's do show do show interface gigabit 02. So our new MAC address is here. Burnt in address is the one that we took there. So BIA burnt in address. And let's just shut it down and do a no shut. Do show interface, no, do show port security interface gig 02. So it doesn't look like it's gonna work the other way around. Let me just see if I can change it on the VPC side. That's just going to let me set the name. Aha, so I might be able to set the MAC address on here. Let's do it as AB. Oh, CA. Set MAC. Does it not let me do that? Should I just see Mac? Set dump. Yeah, set Mac. Oh, is that dump Mac? Yeah, I think that's dump Mac in it. I'm gonna try it. Set dump Mac. Yeah, so it doesn't look like we can change the MAC address on that side. But let's just try for the switch again. do, I'll paste that in again, so 501 001 002. In gig 02. So that's not enabled. In fact, what we'll do, we'll shut down the port. Just go backwards and we'll enable this again. Switch port, port security. We'll do switch port, port security, MAC address. And we'll add that MAC address again. 001 002. Okay, then we'll do now shut, and there we go. So now we've got the violation. So if we just do, we can see that it's still timed out because we registered the MAC address of the switch, and now this MAC address is trying to come through. So we can see that we've got a violation count now of 1. We've got 1 configured MAC addresses, which is the one that we did. Only a maximum of 1 MAC address is allowed, and it's shut down the port, so the port's error disabled. So if we do port security, we can see now that we've got a security violation on the gigabit 02, and it's shut down. As you can see on the left hand side there, we're not passing traffic. So if we do, we could change this, so we could do switch port, port security, MAC address, is it maximum MAC address? That's it, maximum allowed. So we'll do 2. So we'll do a shutdown and a no shut to bring this port back up, and then we should, there we go, so we can pass traffic now. So it's come back up. So if we just do a show again, so we can see that we've got maximum MAC address is 2, total allowed 2, configured 1. Do show port security. So we can see that a violation count is 0, and we've got maximum secure addresses allowed, and current addresses we've got 2, so we're all good again now. So that's configuring port security on the access ports. Okay, so moving on now, let's take a look. So we've done port security and we've violated it, and we've taken a look at that. So what we're going to do now is we're going to disable unused ports and create a VLAN for them. So we'll take a look at unused. So we'll do this on switch 1 again primarily, just to save time. And what we're going to do is we'll do show interface status. And we've got the gig 01, gig 00 that we're using between switch 2 and 1, gig 00, which is gig 01, which is between the router and the switch, and gig 02 in use. So the only one that we're not using is gig 03. So what we'll do is we'll do interface. Now what we'll do is we'll create a VLAN first. So VLAN, we'll call it 100, name, black hole, exit, and then we'll do interface gig 03, switch port, mode access, switch port mode access VLAN 100, switch port access VLAN 100. So if we do show VLAN brief, we can see now that our unused port is in a black hole of VLAN that's not being used. Do show interface brief, IP interface brief. Let's just go into interface VLAN 100, shut down, exit. There we go. So we can see that that VLAN is created now and it's shut down. It's not in use, and the port within it is set to an access as well. So that's our one interface bit that's being put into there. Let's look at our lab details again. So we're going to move the active ports into another VLAN because the VLAN that they're currently on is VLAN 1. So what we'll do is we'll create another VLAN. So we'll call this VLAN. We'll stick to, as per the guide, VLAN 20, name, users, VLAN 20, no shut, exit, interface, so it's on the gigabit 02, switch port access, VLAN 20, do show interface, no, do show VLAN brief. So we can see that we've moved gig 02 now to VLAN 20. Okay. We could do the same for switch 2, so all we'll be doing is just replicating the same. In fact, we'll just do that quickly on this switch. Enable. I won't put the other one in the black hole VLAN, I'll just call it black hole interface VLAN 100 shut VLAN 20 name users interface VLAN 20 no shut interface gig 02 switch port access VLAN 20 do show VLAN brief. So yeah, that's cool, that's done as well now. So moving back to the main switch, switch 1. So we've moved them off of the default VLAN. So let's have a look at the lab guide. So configure private VLANs or PVLANs on switch 1 and test. Okay, so we could do, hopefully the switch supports this. What I'm going to have to do is I'm going to have to power it down and power it back on so we can test connectivity, because PVLANs are locally significant. So normally you implement this to stop devices on the same switch from talking to one another. So let me just see if it's supported before I shut down the switch. Excuse me. Yeah, so it is. So switch port protected. Okay, that's cool. So I'll just exit out of there. I will do right mem, and I'll shut it down. I'll add this VPC to gigabit 03. We'll take it out of the black hole VLAN. We'll give it an IP address. We'll test that we can ping from VPC to VPC, and then we'll enable private VLANs and see what happens. So I'm going to shut this down. And then let's see if we can add, I'm going to have to stop that one as well. Let's see if I can add this to gig 03. We'll start this back up. We'll start the switch back up as well. And we'll give it a few minutes for the switch to come back online. So the switch is back online now. So we'll go into switch port gig 03. Switch port mode access should already be on. Switch port access VLAN 20. Do show. Okay, that one expected. Do show VLAN brief. So gig 03. We're missing gig 02. Do show interface gig 02 switch port. Access. Trunking off. So let's go to interface gig 02 switch port access VLAN 20. Okay, so that's in there. I think I need to configure an IP address on the VPC again. Let's do show, yeah, IP, so we'll give it 192.168.2.10 again. Gateway 192.168.2.1. And then let's just check the switch and make sure. Do show IP interface brief. VLAN 20 is up. protect that off there, so we'll interface VLAN 1, not IP address, interface VLAN 20, IP address 192.168.2.2, 255.255.255.0. Okay, so that's cool. So let's see if we can now ping between the two. Ping 192.168.2.12. So we can ping between the PCs. So I'll leave that on a continuous ping. And now we're going to implement private VLANs, which should hopefully stop this communication. We'll do interface gig 03, switch port protected, interface gig 02, so it's still working as you can see. Okay, so we'll do interface gig 02, switch port protected. We've got one timeout there. It's interesting. Do show interface gig 02 switch port. Okay. Let's see if that still seems to be permitting that traffic between the two. VLAN 20. So we'll look at 3. VLAN 20 static access. So protected true, protected true. That's interesting. So it seems to not have worked. Let me shut down one of the ports. I'll do a no shut. Okay, so I'll do a no shut. Okay, so that seems to bring it back straight away. So 02 20 switch port protected. 03, switch port protected as well. Okay, so the private VLAN edge doesn't seem to be working. Let me just have a look. Switch port. Private VLAN. We shouldn't need to do that. It should just be switch port protected, and it should stop the communication. So I'm gonna have to look into that and see whether it's because it's this virtual device or not. Doesn't seem to be working on there. So I mean, even if we take a look at the guide, the lab manual, it looks as though they've got similar. So, yep, so they've got switch port protected on the interfaces. And it looks the same. Okay, so yeah, so that looks the same. So if I just do so yeah, that's right. So we start getting the timeout there because we've moved it VLAN. Okay, so that doesn't seem to work. I mean, we did see one timeout when we first configured it, but it doesn't seem to have made a difference. Unless... oh, it's saying it's not reachable now. So is that right? Is because it maybe I'll constantly ping in, maybe that's why. So now it says it's not reachable. Let me just take that off. And then I'll do the same. Ah, so there we go. So if I seem to leave the constant ping up and I enable private VLAN edge, it doesn't make a difference. Whether that's because of the environment we're using, I'm not too sure. But then if we now try and ping, okay, so it's going to work again. So if I stop the ping and then I do that, then add it back, let's see. So now it's working again, but we just seen that it stopped working and it wasn't reachable. So maybe it's temperamental. Okay, so on the... let's shut it down. We'll do that. And then we'll enable switch port protection again. And then we'll do no shut. do show interface gig 02 switch port, so protected true. Let's see if we can ping now. So it's still allowing us, but then it stopped allowing us a minute ago. So let's go into, let's show gigabit 03 protected true. So we're pinging from VPC 3, so let's try ping from 4 to get to 2.10. That allows us as well. But we're seeing then that it didn't work. Gig 03 switch port protected. Oops. Let me stop that. And it seems to work. So maybe it's a little temperamental because we scroll a little bit further up here. It was not reachable when I did the test. And is it going to do it again now? So yeah, so now it's doing it again, so it's not reachable again now, which is how it should be. Does that work? So what if I clear app? Does that work? No. Empty again, and it still works, but what about VPC3? Is it going to not work again? Okay, so maybe it's a little bit temperamental with these private VLANs. I've not seen this behavior before, so for those that are watching and maybe done this before, feel free to comment down in the box below. But that's essentially implementing private VLAN edge feature. It's as simple as that. So I think our last task now is to configure DHCP Snooping. So just to kind of quickly summarize, you can see that we've implemented quite a lot of switch security, is what the actual lab is anyway. There's quite a lot of features that you can implement on these devices, if you've seen already. So now we're going to configure DHCP Snooping. So we need to set up DHCP pools. Let me just get off that one now, in fact. So anyways, so we'll go to the router. And we're going to configure DHCP pools for we'll follow the guide on this one, I think. So yeah, so part 4 for those that are following along. So we're going to configure DHCP pools. I'll do this really quick. So we'll do it for VLAN 1, VLAN 20, and we'll configure the router's interface for inter-VLAN routing. So let's start by doing IP DHCP pool, and it's going to be as per the guide, CCNA S for security, network 192.168. We'll walk configure 2.0 because I've moved that to VLAN 20. So in my case, I'll just say let's configure 3.0. No, in fact, no, we will, because I'll just change the IP address. So I'll do 2.0/24 default router. So we don't have to change the IP address on the router. 2.1, and then we'll do exit out of that. IP DHCP excluded address is going to be 192.168.2.1. to 192.168.2.4. IP DHCP pool, and we'll call this 20 users for VLAN 20. Network 192.168. We'll give this 20.0. We'll do default router 192.168.20.1. Exit IP DHCP excluded address 192.168 just 20.1 IP. So yeah, that's two set up there, so that's fine. So what we'll do now is we'll configure the inter VLAN communication on for the interfaces. So be it interface gigabit 01, interface gig 01, shut down. We need to remove the IP address 192.168.2.1, no IP address. There we go. No shut down because we'll put that on the sub interface now. So we'll do interface gig 01.1 encapsulation .1q VLAN 1, IP address 192.168.2.1. Then we'll do interface gig 01.20 IP address 192.168.20.1. In fact, we can't specify that until we do .1q 20, and that's not the native VLAN anyway. So now we'll specify the IP address. We'll do interface gig 01.99. Let me just do show VLAN brief. So that's the native VLAN. So what we'll do is we'll do encapsulation .1q 99, and this is a native VLAN. So if I just do question mark, make this the native VLAN, which it is. And we need to do IP. In fact, no, we don't need to do an IP address on that one. Let's shut. Exit out that one. Now we need to change the interface on switch 1 connecting to the router to a trunk. So we'll do interface gig 01 switch port trunk encapsulation .1q switch port trunk native VLAN 99 switch port mode trunk. Okay, cool. So we need to in fact, let's go back and configure an IP address for that native VLAN. So interface gig 01.99, IP address was 192.168.99.1. And what we'll do on the switches, do show IP in brief. So this is now our VLAN 1 address, so we'll just go interface VLAN 20, not IP address. Our host we're gonna get by DHCP, so we'll leave that for now. So we'll do interface VLAN 1, IP address 192.168.2.2. And we could do the same for the other VLANs as well. So we're going to obtain an IP address from these. So IP, I think we can do it, yeah. So IP DHCP discover offer request acknowledge. So it looks like it's worked. So we can see there now it's got an IP address of 20.2. Is that correct? 20.2. Ah, yeah, because we only excluded the first address. So ping 192.168.20.1, which is a gateway. That works. So now we'll configure DHCP before we do a DHCP request for VPC 4, or the second one. We'll configure DHCP snooping on the switch. So we'll do IP DHCP snooping, IP DHCP snooping, and we'll do information option, IP DHCP snooping for VLANs 1 and 20. And so that we can, so now that we've enabled DHCP snooping for VLAN 1 and 20, and we've enabled snooping globally, we'll limit the number of DHCP requests on an interface. So we'll do, let me just have a look at this. Yeah, so we'll do this on the we'll do it on gig 03 because that's where we've already requested an address. IP DHCP snooping limit rate limit to 10. And then we'll exit out of there. And then we'll do interface gig 01. This is going to be the trusted interface. So this is the interface that I'll be allowed to respond to the requests. So we'll do IP DHCP snooping, and we can see trust here. Do show IP DHCP snooping. So yeah, gig 01 rate limit, so that's unlimited. That's the trusted interface. Every other interface would be not trusted. For the purpose of this, we're only doing the 2. So option 82 on the untrusted port is not allowed. It's enabled for remote ID 5001.001. So let's have a look at do show interface gig 01. 001. That must be the switch interface. So that's cool. So yeah, that's pretty much DHCP snooping in operation, and it's operational for VLANs 1 to 20 as well, which is good. So this basically determines which switch ports can respond to DHCP requests. Allow it, making sure that only authorized DHCP servers can send requests. So in our case, we've got DHCP configured as a server on the router here. So this is going to be the trusted interface here. Everyone else is untrusted, so shouldn't be receiving DHCP responses from that. So they won't be allowed to respond to DHCP. So that's pretty much how it works. So yeah, that's pretty much it. So just before I end, we'll do we'll rate limit gig 02 as well. So interface gig 03, and because we've not configured it on there yet, do show gig 02 is not there. Interface gig 03. So it's gig 02 that we need to do. Yep, so that's better. So we've got rate limit on that as well. Packets per second. So let's do an IP. DHCP discover. We should get an offer. Discover. Oh no, it's not. Oh no, this is VPC4. Sorry, we need to open the other one because we've done minimal configurations on that. So let's do that. IP DHCP discover offer. Can't find DHCP server, so let's check that interface. So switch 1, do show interface gig 02 connected, switch port VLAN 20. Do show VLAN brief. Okay, so let's try it again. Let's see what's going on with this interface. Gig 03. Don't seem to be playing ball. Connected. I keep doing 3, but it's 2 that I should be looking at. so it's not shut down. The gig 02 is the MAC address is in use. Okay, so it doesn't want to play ball. Gig 02 active. Just have a look at free. Stack access. Enabled. Gig 02. Let me just take off the no switch port protected. That shouldn't make a difference, I don't think. No, this one just doesn't seem to want to play ball for some reason. Can we remove the IP? IP Alright, that doesn't seem to be working for some reason. Do show IP DHCP Snooping. That's the same. So it might be something to do with the VPC. So let me try and stop the VPC and I'll restart it. And we'll connect back to that once it's started. This one. DHCP. VLAN 20. Relay, so we shouldn't have to relay. In fact, DHCP Because the pool's configured anyway, so let's take a look at the pool again. DHCP pool. So we've got that one lease address that we know about. Let's see if it actually gets up there. Okay, so they're not going through, so one more look at this switch, but if not we'll call it a day. I think it might be something to do with the actual VPC itself. Zero 2 VLAN 20 access. Okay. 2.2. Interesting. Yeah, so I think that might be the VPC, maybe. I'm going to leave it there anyway because I think I've demonstrated the, well, quite a lot actually, covering the securing the layer 2 switches. At least one of the VPCs was able to get the IP address, which is good. I wonder if, let me put that as final test, I'll put this into the VLAN 1. No switch port. Access VLAN 20. Switch port access VLAN 1. No shot. And then we'll do a yeah, so it seems to be the same. Oh, well, we've got the one working. So for those that have been following along in the lab manual, as you can see, it's a pretty lengthy lab if you want to fully go through it and try and understand what's happening. I modified it slightly to at least try and make it a little bit more interesting, so I hope you found it a little bit more interesting. And yeah, I hope you've learned more about covering layer 2 features that we can apply to further secure our devices as part of the CCNA security. But moving forward also as well, these are also features that are applied if you're looking at certification exams. You know, you'll come across some of these in the CCNP route, and you'll also cover these again in, you know, CCIE security, maybe in a little bit more detail. So it's definitely worth playing around with these and getting used to what they do and how they do it as well.